Artificial intelligence may be humanity's final creation, creating a sort of AI that is so advanced that it can spawn AI beings with even greater intelligence that could change the face of human ingenuity forever. Such beings would outperform human intelligence and achieve superhuman feats. Welcome to Tech Heaven, and in this video we'll take a look at 4 main types of AI. How near are we to developing artificial superintelligence that can outperform the human mind? The short answer is no, but the pace has accelerated since the contemporary field of AI began in the 1950s. Today, interest in and research into artificial intelligence is at an all-time high, with advancements occurring on a daily basis. But it's unclear how near the latest attempts will get us to AI superintelligence or when we'll get there. The 4 major types of AI are discussed here. The first 2 varieties are classified as narrow AI, or AI that has been trained to do a specific or limited range of tasks. The second and third types have yet to be realized and are classified as strong AI. Type 1. Reactive AI. The most basic sort of AI system is reactive machines. This implies they can't develop memories or use prior experiences to impact current decisions. They can only react to current situations, hence the term reactive. Deep Blue, an IBM chess-playing supercomputer constructed in the mid-1980s, is an example of a reactive machine. Deep Blue was designed to play chess against a human opponent with the goal of defeating the opponent. It was programmed to recognize a chessboard and its pieces, while also comprehending the functionality of the pieces. Deep Blue could forecast what plays it should make and what moves its opponent may make, giving it an improved capacity to foresee, select, and win. Deep Blue defeated Russian chess grandmaster Garry Kasparov 312-212 games in a series of matches conducted between 1996 and 1997, becoming the first computational program to overcome a human opponent. Deep Blue's unusual ability to play chess matches properly and successfully highlights its reactive talents. In the same line, its reactive mind shows that it has no idea of past or future. It simply comprehends and acts on the world and components within it that exists now. To put it simply, reactive machines are programmed for the here and now, but not for what came before or after. Because reactive machines have no sense of the outside world, they are unable to function beyond the simple duties for which they are programmed. Reactive machines have the property of always behaving the way they are programmed, regardless of time or place. With reactive machines, there is no progress, only stasis in recurrent actions and behaviors. Type 2. Limited memory machines. The deep learning revolution began in 2012. Based on our understanding of the brain's underlying mechanics, an algorithm was created that could mimic how our neurons link. Deep learning has the property of becoming smarter as more data is trained on it. Deep learning significantly increased AI's picture recognition skills, and new types of AI algorithms such as deep reinforcement learning quickly emerged. These AI models were far better at absorbing the properties of their training data, but perhaps more importantly, they improved over time. Google's AlphaStar project, for example, defeated top professional players in the real-time strategy game StarCraft 2. The models were designed to work with poor data, and the AI played against itself frequently to acquire new strategies and perfect its judgment. In the StarCraft game, a player's early decision may have far-reaching consequences later on. As a result, the AI has to be able to forecast the outcome of its actions ahead of time. The same concept can be seen in self-driving cars, where the AI must predict the trajectory of nearby cars to avoid collisions. The AI in these systems bases its decisions on past data. Reactive machines, needless to add, were incapable of dealing with such situations. Despite all these breakthroughs, AI still lags behind human intelligence. Most notably, it requires vast volumes of data to master simple tasks. While the models can be retrained to grow and improve, changes to the environment in which the AI was trained would necessitate retraining from the ground up. Consider the following language. Acquiring a second language makes learning a third and fourth language much easier. For AI, it makes no difference. Machine learning models that generate knowledge from previously learned information, stored data, or events have limited memory. Limited memory, as opposed to reactive computers, learns from the past by monitoring actions or data provided to it in order to gain experiential knowledge. Although limited memory is built using observational data combined with pre-programmed data already present in computers, these sample pieces of information are transitory. Autonomous vehicles are a type of limited memory that already exists. Autonomous vehicles, often known as self-driving automobiles, operate on the idea of limited memory, relying on a combination of observational and pre-programmed knowledge. Self-driving cars read their environment, recognize trends or changes in external elements, and adjust as needed to monitor and comprehend how to correctly drive and function amid human-dependent vehicles. Autonomous vehicles not only observe their surroundings, but they also observe the movement of other vehicles and persons in their line of sight. By the way, if you're watching us for the first time, make sure to hit that subscribe button and turn on notifications so you can enjoy our future videos while getting updated. Getting back to the topic, Type 3, Theory of Mind. The ability of an AI machine to attribute mental states to other entities is referred to as theory of mind capabilities. The phrase is drawn from psychology and needs AI to infer creatures' movements and intentions. Emotion AI is currently being developed with the goal of recognizing, simulating, monitoring, and appropriately responding to human emotion through the analysis of speech, image, and other types of data. However, while this capability has the potential to be invaluable in advertising, customer service, healthcare, and many other areas, it is still far from being an AI with theory of mind. The latter is not only capable of varying its treatment of humans based on its ability to detect their emotional state, but is also capable of understanding them. Indeed, understanding, as it is commonly characterized, is one of AI's major impediments. The type of AI capable of creating a masterpiece portrait still has no idea what it has created. It is capable of producing lengthy essays without understanding a single word of what it has spoken. This constraint would be overcome by an AI that has progressed to the theory of mind state. Type 4, SelfAware AI. The sorts of AI outlined above are antecedents to self-aware or conscious machines, that is, systems that are aware of their own internal state as well as their interior states of others. This simply means an artificial intelligence that is on par with human intelligence and can simulate the same emotions, desires, or requirements. This is a long-shot aim for which we lack both the algorithms and the technology. This type of AI does not currently exist, but it is the most advanced form of artificial intelligence known to man. It remains to be seen whether artificial general intelligence and self-aware AI are linked in the far future. We still know much too little about the human brain to create an artificial one that can compete with it. Aspects of self-aware AI include the ability to think for itself, have desires, and understand its thoughts, in addition to recognizing and replicating human-like actions. In essence, self-aware AI is a development and extension of theory of mind AI. Whereas theory of mind focuses solely on human comprehension and replication, self-aware AI goes a step further by indicating that it can and will have self-guided thoughts and reactions. We are already in tier 3 of the 4 forms of artificial intelligence, thus reaching the 4th tier does not appear to be a far-fetched thought. However, for the time being, it is critical to concentrate on improving all areas of AI types 2 and 3. Sluggishly progressing through each AI layer may be hazardous to the future of artificial intelligence for future generations. And with that being said, it's time to end our video. Do you think AI is the best human invention, or is it the worst? Let us know in the comments. Like this video and make sure to subscribe to the channel for more amazing videos like this. We'll see you in the next video.